Here, a visinode is created to show a "Hello World" example. There are many ways to display a printout. We can use the vprint function available from visifront, a visinode called print from a library, a direct HTML element, and etc. To add code to a visinode, click on the left-hand top corner and select Edit Script, and then enter the code between script and script. A visinode should be functionally complete, or as much so as possible. This helps programmers get straight to the point, and the need to know how the whole page operates is reduced. A code for linear vertical motion is added to the visinode. Here, the visinode propels itself. The animated visinode may contain live activity, images, movies, or other visinodes. And just like the Matryoshka doll, the new visinode is cloned, and the clones are injected into the original as moving children. Similar code is written to spin a still picture. The record label is a still picture endowed with a spinner code. A pre-written visinode able to analyze the pixels within its perimeter is added. In this particular example, the eye, as we call it, examines colors. A visual sensor of this kind is versatile indeed, and can be anything from a feedback and simple process control loop to a kernel in an AI convolution network. In this example, we will make use of color. To make things more exciting, we will create a bar visinode which height is proportional to the color intensity. We start with the red bar and include its identification inside the eye code. Note that the eye is about as formidable as a visinode code gets. Most visinodes are simpler. The eye visinode, blue border square, computes a simple color average within its perimeter. The maximum color intensity is 512 pixels. Once the red bar works, we clone it 2 times and paint the clones green and blue. The identity of the bar clones is simply dragged into the eye code window and referenced in the code. Quick and simple, minimal brain job. The sampling rate of the color sensor is set at 10 samples per second, 100 millisecond intervals. Here the video speed is boosted to 400% for a quick demo, thus the speeds don't match. As the eye hovers over a given color, the color components are displayed in the vprint on the right side of visifront. Please pause the video to inspect the color values. Once our color bar graph is operating, we need to add something that is able to make decisions. So a simple pre-written code, we call WD level monitor, is added to the visinode containing the bars. This is similar to the comparators we humans have used over the years for electronic process control. Our level monitor returns high if the red bar is over its high limit, low if it is under the low limit, and box if it is within limits. The eye function calls the WD level monitor to ask if the given color value is within limits. Whereas, the cloned WD level monitors are given the suffix R, G, and B, all the colors are tested individually. As follows, we write a statement that delivers bingo when all the colors are inside their respective limits. The user can adjust the vertical position and height of the level boxes to set the conditions that trigger the action. Similarly, the eye borders should be fitted around the object being watched as tightly as possible. Our trigger conditions are set when all the colors are within limits, and reset if this is not true. The user may choose what happens on both set and reset. Visinode doesn't care what video it is inspecting, so we will see if visinode can detect ocean waves. And sure enough, it bingos whenever a wave passes through the parameter of the blue eye borders. We have shown how to create a visinode. It is also possible to inject code. Let's create a color calibration wheel using visinodes only. We will use the spin code we wrote earlier. Remember the record label? Now we drag 2 spinners into visifront. The record label is a stationary picture. Tap the Alt key and then drag a spinner into the record label while holding the Control key down. This will spin the record label for this example. With the parent visinode spinning, we can add live visinodes to the parent. For fun, pictures of bananas are added to the color wheel, to suggest a real-life process control. The visinode output can trip a solenoid, removing ripe bananas by color from an assembly line. We erase the bananas and create a white visinode clone and then color the clones to create our calibration wheel. If we clone the eye function, the new clone must share resources with its original. Observe how the color bars oscillate between the clone and its original. We should have cloned the eye function along with its entire family, that is, all the bars and the level monitors, so no matter where the cloned eye function is located, it is always entangled with family members. Finally, we can create a visinode family from our previous work, where family members get entangled. This allows us to have multiple eye visinode watching over multiple events on the video. Visinodes don't care if the video is a live web camera or a recording, it doesn't know the difference. It may be useful to display a QR code that contains the web address of this application. For the final demo, a smartphone records another smartphone watching over a door handle. The eye visinode is linked to audio containing a barking dog. If a bar violates the conditions, the dog barks.